Hi, happy Monday everybody and welcome to Maths with Kirin. Now this is the second to last teaching video that I'm doing as part of this Level 1 Algebra series. So today we're still sticking with simultaneous equations that we covered in our last lesson, but we're going to be focusing on using the elimination method to solve those today. So as I said in that last video, it's really useful if you can have both the elimination method and the substitution method in your toolkit. Just means that you can be a little bit more versatile when you come across different sets of simultaneous equations, and you can pick and choose which one you feel more comfortable with, given what the equations might look like that you need to solve. So we'll get started. As usual, I've got a few examples. So 4 examples to go through today, just to show you the skill and how you might need to use it. And then I've got 4 exam questions to go through. 2 of them are the same ones that I did in the substitution lesson, just so you can see how it might look different using the elimination method. And then I've got 2 new ones as well to go through today. So, simultaneous equations. Using the elimination method, we're going to add or subtract the equations. And we're going to do that to deliberately eliminate one of those 2 variables. Okay, so instead of substituting in, we're adding or subtracting equations. So before we add or subtract, the one thing we need to make sure that we have is the same coefficient for one of the variables in both of those equations. Okay, so it might mean that you have a 4x in the first equation and a 4x in the second equation. And in that instance, we would subtract the equations because 4x minus 4x would give us no more x's, so we've eliminated the x terms. If, for example, you have a 3y and a negative 3y, then that would work as well. In that case, instead of subtracting the equations, we would need to add them, because 3y plus negative 3y would give us 0 y's, so we've eliminated the y terms and we'd just be left with some x terms to solve. That sounded confusing. Hopefully all will be cleared up when I go through some examples with you. So in order to get that same coefficient for just one of the variables, we may need to multiply either one or both equations so that we can get that variable to be the same, and then we can add or subtract the equations from there. Once we've eliminated one variable, we can solve for the remaining one, and as usual, once we know the value of that first variable, we can substitute into our original equations in order to find the value of that second variable, the one that we eliminated to start. So it might sound kind of technical and a bit tricky, but we'll go through some examples and hopefully get you all up to speed. So for my first example here, we've got 5x plus 4y equals 49 and 5x plus 2y equals 27. When you're using the elimination method, it is a really good idea to line your 2 equations up so that you have x's on top of each other, the y's and the constants, in whatever order you have them in, so that they're all the same. It will make the adding or subtracting much easier and you'll be less likely to make errors. So you'll notice that we've got a 5x in both of those equations, so we can eliminate our x term. To do that, because they're both positive 5x's, I'm going to need to subtract. So I tend to put my second equation in brackets and a subtraction out in front so I can remember that I'm subtracting and I get the result underneath. So 5x minus 5x is no x's. 4y minus 2y is 2y. And 49 minus 27 is 22. So we've eliminated our x. We know that 2y is equal to 22, so solving a linear equation, y is 22 divided by 2, so y is 11. We've already found one variable. Going back, in order to find x, we can use either equation, doesn't matter. I'm just going to use the second equation. So we know from here, 5x plus 2y is equal to 27. So 5x would therefore be 27 minus 2y. And we know that y is 11, so 27 minus 2 times 11 is the same as 5x, which means 2 times 11 is 27 minus 22, so 5x is equal to 5, which means x is equal to 1. So we've got 2 solutions, x is equal to 1, and y is equal to 11. Again, if you're unsure or you just want to double check, make sure you haven't made any errors, then you can substitute in here. So 5 times 1 is 5, 4 times 11 is 44, 44 plus 5 is 49, and then you can also check in that second equation. It pays to check both of them. Sometimes it might work for one equation, but not for the other, depending on what the error was. Okay, so in this case, subtracting the equations meant that we eliminated our x variables. So we just solved for y first and then substituted for x. Example number 2, we've got 6x minus 4y equals 28 and 4x plus 4y equals 24. So you'll notice we've got a 4y in both of those equations. So we're going to eliminate our y term. But because we have a negative 4y and a positive 4y, the signs are different. Instead of subtracting the equations, when the signs are different, you add the equations. I don't know if that helps anyone, but if the signs are different, you add them. It's got two D's and different signs. Might help you to remember what you're doing. So when we add these equations, 6x plus 4x is 10x, negative 4y plus positive 4y is no y, and then 21 plus 24 is going to give us 45. So 10x is 45, x is 45 divided by 10, so x is 4.5. Okay, so we can get decimals. Even though you're not allowed a calculator, this is a relatively straightforward calculation, so it's possible you can get something like this. Substituting back, we need to find y. I'm just going to use the first equation, or the second equation, doesn't matter. In fact, I might use the second one. So we know that 4y is equal to 24 minus 4x when we bring that x to the other side. So 4y is 24 minus 4 times 4.5. So 4y is 24 minus, well, 4 times 4 is 16, and 4 times 0.5 is 2, so 16 and 2 means that we get 18. So 4y is 6, which means y is 6 over 4, and we can simplify that down to 3 over 2, or you might write 1.5. Doesn't matter, either will be accepted. So our two solutions, x is equal to 4.5 and y is equal to 1.5. And if you wanted to, go back and check that they both work. Okay, so relatively easy decimal to that particular question. The signs were different this time, so we added our equations in order to eliminate that y term. So our third example, 2x plus y is 14 and 4x plus 6y is 36. So at the moment, the x's and the y's all have different coefficients, so I can't just add or subtract them as they are. I'm going to need to do some manipulation first. So if we call this equation 1 and equation 2, to make the x terms the same, we could multiply this top equation by 2. If you wanted to eliminate the y terms, you could multiply the top equation by 6. I'm going to multiply it by 2 just because it's a smaller number, so it might make it a little bit easier. So I'm going to take my first equation and multiply it by 2. So this becomes 4x plus 2y equals 28, and our second equation doesn't change. Okay, so we've got 4x and 4x, so we're going to subtract the equations. The signs are the same, so you subtract them. Some people, when you obviously look at this, when you go 2y minus 6y, you're going to get a negative, and that's fine. Some people prefer to write these the other way around so that you end up with a positive y and a negative one. So if you prefer to do that, that's absolutely fine, but it will make no difference because we'll just solve it and get the right answer anyway. So I'm just going to leave them as they are, but if you prefer, you can write this second equation on top so that you end up with a positive y. If we do it this way around, 4x minus 4x is nothing, 2y minus 6y is negative 4y, and then 28 minus 36 is negative 8. So negative 4y is equal to negative 8, which means y is negative 8 divided by negative 4, which is positive 2. Okay. Substituting in to find x, I'm going to use the top equation. So 2x is equal to 14 minus y. So 2x is 14 minus 2. So we just figured that out, which is 12. So x is 12 divided by 2, which means x is 6. So two solutions, x is equal to 6 and y is equal to 2. One more example and then we will look at some of these exam questions. So we've got 2x plus 3y is 23 and 3x plus 4y is equal to 32 for this last example. So here, again, x's have different coefficients and y have different coefficients. So I'm going to need to manipulate. I could multiply this by 1.5, I guess, in order to get 3x, but that means that we're going to have decimals. So probably not what I would recommend doing. And then with the y's, again, I can't multiply by a whole number in order to get those the same. So in this case, we're going to multiply both equations so that we can get the same coefficient. So you could get the y's the same, in which case I would use 12y. So I would need to multiply the top equation by 4 and the bottom equation by 3. Or you could eliminate the x's by making them both 6x's. So we need to multiply the top equation by 3 and the bottom equation by 2. So that's what I'm going to do. I prefer, if I can, to multiply by smaller numbers so that I have smaller numbers to deal with. So we're going to take equation 1 and multiply it by 3. So this becomes 6x plus 9y equals 23 times 3. So 20 times 3 is 60 and 3.3 is 9. And then we're going to take equation 2 and multiply it by 2. Okay, and if I number those. So 3x times 2 is 6x. 4y times 2 is 8y, and then 32 times 2 is 64. Again, we've got a positive 6x and a positive 6x, so we need to subtract that second equation. 6x minus 6x is nothing. 9y minus 8y is 1y, and then 69 minus 64 is 5. So we've already found y. Y is equal to 5. From here, finding x, I'm going to use the top equation. So 2x is equal to 23 minus 3y. So 2x is 23 minus 3 times 5. 2x is 23 minus 15. 23 minus 15 is 8. So x is equal to 8 divided by 2, which is 4. So two solutions, x is equal to 4 and y is equal to 5. Again, you may want to substitute just to double check, particularly in an exam situation. Okay, so in that particular example, we had to multiply both equations in order to get that coefficient to be the same, and from there we could eliminate. And you can see, while it's possible to use the substitution method, if we did that, making x the subject means we need to multiply these by 2, so we end up with fractions. And same thing here, we don't have a common factor that we can divide everything through by. So I would certainly prefer to use elimination for this kind of question, just so I can keep dealing with whole numbers. That makes it a bit easier. So this question we looked at in the substitution video. So it's from last year's paper. It's the equation of a straight line. So it passes through the point -5, -10, and 9, 11. And we know it's given by this equation here, qy equals px plus 5. We want to use algebraic methods to find the numbers p and q. So we're going to start in the same way that we did with the substitution method by writing out our equation. So we used our points to do that. This is x and this is y. So if y is -10, we've got -10q is equal to -5p plus 5. Just substituting x and y in here from those values. And then our second equation comes from using the 9 and 11. So 11q is equal to 9p plus 5. Okay, those are our two equations. So for our substitution method, we divided this by 2, made p the subject, and substituted it in. For elimination, we need to get either the q's or the p's to have the same coefficient. So at the moment, we're going to need to do some multiplying in order to get that same coefficient. So I'm going to eliminate the p's first by making them 45. So that means that equation 1 is going to be multiplied by 9, and equation 2 I'm going to multiply by 5. So when we do that, we get -90q equal to -45p plus 45. And for our second equation, and multiplying it by 5, we get 55q is equal to 45p plus 25. So from here, we've got a negative 45 and a positive 45. So we need to add our equations this time instead of subtracting. So negative 90 plus 55 is going to give us negative 35q. Bring our equal sign through. Negative 45p plus 45p is nothing. And then 45 plus 25, 40, 60, 70. So we get negative 35q is equal to 70. So q is 70 divided by negative 35, which is negative 2. Okay, once we've found q, going back to here in order to find p, I'm going to use the top equation. So we know that negative 5p is equal to negative 10q minus 5. That means that 5p is equal to 10q plus 5. So multiplying everything through by negative 1. 5p is equal to 10 times negative 2, which is our q value from here, plus 5. 5p is negative 20 plus 5. So 5p is negative 15, which means p is negative 3. Okay, in assessment, some of you might do a lot of this quite quickly. You don't have to write out all of these lines of working that I'm doing. I'm just making sure it's really clear so people can follow how we get from one step to the next. I would recommend writing out the equation that you're going to use to solve for that second variable, but then you might skip down to this and then your negative 3 if you're comfortable doing that. If you prefer to write out all of the steps of working, because for you that means that you're less likely to make an error, then by all means, just do whatever works for you. Just make sure that you've got some working so that we can see the algebra you're using to solve these questions. Okay, so I would certainly write out what you're using. I'd probably write maybe one more calculation line before you do the solving. So for this question, the marking schedule obviously hasn't changed since I went through this with you in the last video. So for achieved, you form both equations, or you consistently combine your equations into one variable. So you might get these incorrect. You might do the x and the y's around the wrong way, for example. If you can consistently take those incorrect equations and eliminate one variable, that would still give you achieved. You've shown an achieved level skill. Or if you get a consistent solution for one variable, so again, your equations might be incorrect, you can get a consistent solution, then that will give you achieved. For merit, you correctly find one of P or Q, but you don't find the other, and then for excellence, you need both P and Q for that question. Cool. So next question again is another one that I went through in the substitution video. So it's from the 2018 paper. George and Leo, you'll remember, are organising 27 people into two groups. They've got students and adults. We know tickets for this particular event, sports event, are $20 for students and $30 for adults. We're told that the cost of the tickets is $650 for those 27 people. We know half of George's group of students and 2/3 of Leo's group of students, and the question is asking how many students are in Leo's group. So lots of information for this one. Again, we're going to start in exactly the same place by writing out our equations. So the first thing we need to do is use the information that we have for students and adults in order to find how many students and how many adults we have in that group of 27. Once we've done that, we can use this information in order to find out how many people we have in Leo's group, and then we can find how many students. So quite a lot of steps with this one. So 27 people. We said A was the number of adults. You can use X if you want to. That's absolutely fine, whatever you feel comfortable with. And we used T for the number of students last time, so we'll just keep that consistent. So we know that the number of adults and the number of students has to equal 27. And we know the cost of the tickets and how much they paid in total. So 30 times the number of adults plus 20 times the number of students has to equal 650. So if we want to use elimination to solve this question, we need to get our coefficients of either A or T the same. So we just number these. In order to do that, I'm going to multiply equation 1 by 20. Okay, so we get 20a plus 20t is equal to 27 times 20. So if you go 27 times 10 is 270, and we double 270, we get 540. And our second equation is still the same. We've got 20t and positive 20t, so we're going to subtract. The signs are the same, so we subtract. Again, some people might write these the other way around with this one on top so that you don't have to deal with negatives. If you feel more comfortable with that, then by all means. I'm just going to plow through as I've written them. Yeah, so 20a minus 30a gives us negative 10a. And then 540 minus 650 gives us negative 110. And 20 minus 20 obviously was 0. So a is negative 110 divided by negative 10, which is positive 11. Substituting back into the top equation will make it much easier in order to find t. So t will be 27 minus a, which is 27 minus 11, which is 16. So we know that there are 16 students. So back to the question, half of George's group of students and 2/3 of Leo's group of students. So if we use L for the number in Leo's group, and G is the number in George's group, because we know that there are 16 students, our equation, half of the people in George's group plus 2/3 of the people in Leo's group are students, so they must add to 16. You could write a second equation, half G plus 1/3 L equals 11 using the adults, because obviously if half of George's group of students and half of the adults, and if 2/3 of Leo's group of students and 1/3 of the adults, I prefer to use this equation. I did that last time as well. We know that the number of people in George's group plus the number of people in Leo's group still have to be 27. So I'm going to use that equation, but you can still get the right answer if you use the equation for adults. So from here, we need to get the same coefficient. So I'm going to multiply, if we just call this 3 and 4, I'm going to multiply equation 3 by 2. Because when I double that, I'm going to get G, which means I can eliminate my G. So we get 1G plus 2/3 doubled is 4/3, and 16 doubled is 32, and then we've still got this. Positive G means we need to subtract. G minus G is nothing. 4/3 minus 1, well 1 is the same as 3/3. That helps. So 4/3 minus 3/3 gives us 1/3 of L, and 32 minus 27 is 5. So if 1/3 of L is 5, then L must be 5 times 3, which is 15. So we know there are 15 people in Leo's group. So the number of students in Leo's group is 2/3 of 15, which is 10. Okay, so because we told 2/3 of Leo's group of students. Okay, and if there are 15 people in Leo's group, then 2/3 of that is 10. So lots going on in that question. For achieved, you write your two equations correctly. The top or one of the equations is correct, and you eliminate one variable. Okay. For merit, you correctly solve these first two equations to get 11 adults and 16 students. So you need to get both of those in order to merit. Or you use algebra to find the number of people in either group. So the 15 or however many are in George's group. Or your simultaneous equations are consistently solved. So that means that you don't have the right equations, but you solve the ones that you have written in order to find the number of students in Leo's group. So maybe something went wrong up here, but you consistently work that all the way through and you get the number of people in Leo's group that is correct for the equation that you started with. And then for excellence, you need to get the correct solution of 10 students in Leo's group, making sure that you're showing the algebra that you're using as you go through the question. Okay, or there needs to be some sort of evidence of importance. Okay, so that might be a slightly more difficult question because there's just quite a lot of information, quite a lot going on. Cool. So I've got two more questions to go through. These are from the 2017 paper and are ones that I haven't been through before. Okay, so this first question doesn't have any context and it gives us the equation. So it says if 6x minus y is equal to 21 and negative x plus 6y is equal to 14, what is the value of x minus y? Okay, so we can use our simultaneous equations to find the values of x and y, and then once we know that, we can do our subtraction. So if we write out our two equations as we have them, negative x plus y. Okay, so at the moment we don't have any coefficients the same for either x or y. So we're going to change that. And so I'm going to multiply the second equation by 6. So I'm going to eliminate the x terms first. So equation 1 stays the same, 6x minus y equals 21. And then I'm going to multiply the second equation by 6. So we get negative 6x plus 36y is equal to 14 times 6. So 10 times 6 is 60 and 4 times 6 is 24. So 60 and 24 is 84. Cool. Positive 6x and negative 6x. So this time we're going to add the equations. 6x plus negative 6x is nothing. Negative y plus 36y is 35y. And 21 plus 84 is 105. So that means that y is 105 over 35. Now, if you don't know what 105 divided by 35 is, you might do some side, see if you can figure it out. Or you might recognize that you can divide both 105 and 35 by 5. So 105 divided by 5 is 21, and 35 divided by 5 is 7. And then we can simplify that to 3. So that works. So y is 3. Substituting to find x, so I'm going to use the second equation. Negative x is equal to 14 minus 6y. 14 minus 6 times 3. 14 minus 18. Remember, this is negative x. So negative x is negative 4, which means positive x is positive 4. Okay, so the question was asking us, remember, to find the value of x minus y. So if x is 4 and y is 3, x minus y is 4 minus 3, which is 1. Okay. So for that question, if you solve it this way, to get achieved, combine your equations into one variable. Okay, so that's eliminating one variable, so getting down to this step here, this 35y equals 105. Or if you eliminated your y's, whatever you get for x. Or you find a consistent solution for one variable. So again, something has gone wrong somewhere once, and you work that error all the way through and you get a solution for one variable that's consistent with the error that you made. Or you get just a consistent solution for x and y. Or for merit, you solve for one variable correctly, so you get either x is 4 or y is 3. Or you get 2 or more of those procedures for achieve, so you combine into one variable, and then maybe something goes wrong, you get a consistent solution. Okay. And then for excellence, you need the correct solution to the problem, so you need the x minus y. You can solve this question another way. So if we just take our equations, we've got 6x minus y equals 21, and we've got negative x plus 6y equals 14. I wouldn't have done this. I would have, if I had this question in the exam, I would have used simultaneous equations to solve it. But some of you may have spotted that there is a different way. So if I make these both equal to 0, we get 6x minus y minus 21 is equal to 0, and we get negative x plus 6y minus 14 is equal to 0. So if this is equal to 0, and this is equal to 0, then they must be equivalent. So that means that 6x minus y minus 21 must be the same as negative x plus 6y minus 14. It's kind of like a substitution method. So if we simplify by putting all of our x's and y's onto the left-hand side and the numbers onto the right-hand side, let's see what happens. 6x When I bring my negative x across, I need to add it to both sides, so we get 7x. Negative y, when I bring the 6y across, I need to subtract it from both sides, so negative y minus 6y is negative 7y. Negative 14 stays where it is. Bringing the negative 21 across, I need to add it, so negative 14 plus 21 is positive 7. We've got a common factor of 7 here, so taking that out of front, we get 7, and then a bracket x minus y is equal to 7. So if we divide through by 7, we get x minus y is equal to 7 divided by 7, which is 1. Okay, so that happens to work in this particular case. It may not always work, but that is another way that you can solve this question. And if you solve it this way, you still get full marks, you still get that excellence. If you solved it this way, then just trying to find my notes. Sorry. If you solved it this way, to get achieved, you combine your two equations by either equating them together, or you might try and add them or subtract them without changing the coefficient, so that will give you achieved. You might remove your common factors, or find a consistent solution when you've sort of tried to combine them this way. So you can get achieved, and then again the merit starts to apply. So 2 or more of those achieved procedures for solving for one variable. So that's just a different way that you might at solving that particular question. So last question for today, also from the 2017 paper. So we've got some more words. We've got Tane and Pete raising funds for their sports trip. Between them, they need to raise $1,000. There are 5 weeks until they need the money. We've got 5 weeks to raise $1,000. Tane gets paid $15 an hour, and Pete gets paid $16 an hour. He has more experience. Between them, they work for a total of 13 hours per week. What is the average number of hours that each of them work per week if they are to have exactly the amount of money they need? Okay, so they need to get $1,000, and they have 5 weeks in order to do that. Tane gets paid $15 an hour, Pete gets paid $16 an hour, and between them, they work a total of 13 hours per week. Okay, that's important. So if we say that T is the number of hours Tane works per week, and then P is the number of hours Pete works per week, we can start to write our equations. So we do need to take note that we're doing this in terms of each week. So we know that they together work 13 hours, so the number of hours that Tane works plus the number of hours that Pete works has to be 13. They need to raise $1,000. They've got 5 weeks to do that. Okay, so per week they don't need $1,000. Per week they need $1,000 divided by 5, so $200. So when we're running our second equation, Tane gets paid $15 an hour, Pete gets paid $16 an hour, and they need to get $200 per week. Okay, so that second equation is only equal to 200 because we're doing this per week. From here, we would solve. So if we're using elimination, we can multiply our first equation by 15. So 15t plus 15p is equal to 13 times 15. So when we do that, we get 195. Times it by 10. And you guys can have that. If not, you can write 13 times 15 this way, or you can go 13 times 10, 13 times 5. Our second equation stays the same. Because we have positive 15 and positive 15, we're going to subtract our equations. And again, if you don't like having the negatives, write them the other way around so that this equation is on top. But if you're not fussed, then we can just carry on. So 15p minus 16p is negative p. Then 195 minus 200 is negative 5, which means p is positive 5. Okay, and then substituting in here, t is equal to 13 minus p, 13 minus 5, which is 8. Okay, so that means that Pete works 5 hours a week on average, and Tane works 8 hours a week on average. Okay. So for this question, for achieved, you identify your equation in terms of P and T for the total amount to be earned per week, or you consistently establish your equation in one variable, so getting down to here, or consistently calculating the number of hours that Pete or Tane worked. But again, that whole idea about consistency means that something might have gone wrong in one of these equations. And so when you follow that error through, your answer won't be 5 or 8, but it will be consistent with what you started with, the equation you had. For merit, you consistently find the number of hours that Pete and Tane worked, or you correctly establish the equation in one variable, so that's getting this bit correct. And for excellence, you solve the problem. Okay. So for merit, sorry, you get one of these correct. For excellence, you get both. Okay. The other way that you could solve this equation is, instead of thinking about it in terms of per week, you might do it for all 5 weeks. So if you do that, your equation will change slightly. So you would still have your 15t plus 16p, but that would equal 1,000 because we're thinking of over the 5 weeks. And your t plus p, the total number of hours that they work in 5 weeks would be 13 times 5. So this equation here would change to t plus p equals 65. So if you use this, and you solve it through, you will get the total number of hours they worked for all 5 weeks. The question is asking for the number of hours that they work per week on average. So you would need to divide those solutions through by 5 in order to get the 5 and the 8 that we get here. Okay, so you can solve it for the whole 5-week block, but you just need to make sure that you actually answer it as a per week solution, not as a whole 5-week thing. So just do that. Okay. That brings us to the end of all of the examples for solving the simultaneous equations by elimination. You're probably sick of them by now. I still find them somewhat fun for some weird reason. Hopefully some of you guys enjoy solving these as well. On Wednesday, I'm back. So problem solving sort of style questions, so things that come up in your exam that might not fit into some of the other categories quite so nicely. So on Wednesday, I'm expecting to really just go through a few old exam questions and show you how you can sort of go through some of those more purely questions you might not be expecting quite so much. As always, if you are working through some old exam papers and you've got some questions, feel free to email them through and I can deal with those on my Thursday session. Otherwise, happy studying. The MCAT is coming around rather quickly. So all the best for that study. Email through questions. Please share the Maths with Kirin link either to the YouTube channel or to the Facebook page. That would be really awesome. If you can like and subscribe. If you've got any feedback for me, that would be really awesome. I'm at the moment just trying to gauge whether this has been helpful for people, and if it has, then I might look at doing another block of videos for either tables, equations, and graphs or geometric reasoning, starting in a couple of weeks' time. So if you have found it useful, please do let me know. And if there are some people keen for more of this sort of stuff, then I will certainly look to do that. I'll let you know. So feedback is awesome. If you have any constructive criticism about things that you think we could do better, then let me know nicely, and I can take that feedback on board. Have a lovely Monday evening, and hopefully I will see some of you back on Wednesday for the last sort of lesson.